incoming currents are present right here. Okay, and those incoming currents are I2, I1 and I6. Okay, so these incoming current at particular node is equal to the outgoing currents. So what are those outgoing currents? As you can see right here, these arrows represent the current is leaving from that particular node. Okay, so this I3, I4, I5, these three currents are outgoing currents. Okay, so these currents, outgoing currents, should be equal to the incoming currents. So these three branches are there: I1, I2 and I3. These three currents will present right here. So we have a particular node right here. This is a particular node. At this particular node, we have to calculate the current. Okay, so what is the equation right here? I is equal to I1 plus I2 plus I3. Okay, this will be the equation. This will be the equation for this particular circuit, KVL. So in any closed path, mesh or loop of an electronic circuit, the algebraic sum of product of current and resistances in each of the conductor plus the algebraic sum of electromagnetic forces in that closed path is 0. Some voltage here, we will consider the potential difference. Okay, so right here the potential difference, okay, or potential is increasing. Okay, so here this potential is increasing, we will consider the convention as positive. Here this potential is decreasing. After this resistor, some, this is resistor. What is the definition of resistor? It will oppose the flow of current. So if it will oppose the flow of current, then potential will be dropped right here. Okay, so this convention we will take right here as a negative. Okay, again you will take positive convention at the starting of this R2, and then we will consider the negative convention after the register. Okay, so you understand how we will take the sign convention of this particular circuit, then we will apply the Kirchhoff's voltage law. Okay, so this 9 minus V1 minus V2 minus V3 is equal to 0. There is no phase difference in case of resistor. Okay, so voltage and current remain the same. Okay, in the same direction voltage and current flow in case of resistor. But when we discuss about the inductor, okay, when we discuss about the inductor, the phase difference is pi by 2. Okay, the phase difference is pi by 2. Voltage and current are in the same. There is no phase difference right here because voltage and current will flow through in the same direction. Okay, or we can say purely inductive circuit, then this voltage and current phase difference is 90°. Okay, so voltage will increase. Okay, voltage will increase right here by 90°. Okay, or this is the RL series circuit. R and L both are in series connected with some AC source right here. Okay, and when you connect these two components in series, so current will remain the same but voltage will divide. So across this R, voltage, or we can say potential difference, is VR, and across this L, what is the potential difference? VL is the potential difference. So we will take the input voltage Vm sine of omega t. Okay, clear everyone? So how you can represent this? V is equal to Vm sine of omega t. What is Vm? Anyone know about this? What is Vm? What is Vm? Quickly give your response. Let's suppose that this is your sinusoidal waveform. This is your sinusoidal waveform. So right here, what is Bm? The maximum voltage. Okay, maximum voltage right here. Let's suppose that this y-axis will represent the voltage, okay, and here you can check the current value. So this is the maximum voltage right here. So we can represent it as a amplitude. Okay, this Bm will be represented as a amplitude. What is sine? Sine will represent this sinusoidal waveform. What is omega t? Omega represent 2 pi f. Okay, and we will calculate the voltage. So across this register, what is the voltage? Voltage is VR. Okay, across this register, what is the voltage? Voltage is VR. And how you will calculate that voltage? VR is equal to I into R according to Ohm's law. So some current is flowing through this circuit, that is I, and some resistance is present across this resistor is R. So that's why we will calculate this VR is equal to I into R. Now we will use the inductor right here. So across this inductor, what is the potential difference? Potential difference is BL. So how you will calculate? According to Ohm's law, V is equal to IR. Same thing is here. So resistance across this inductor is XL. Okay, or phasor angle or phasor diagram right here. So when we will draw the phasor diagram, we will take the two axes. Okay, one axis across this register, that is VR, that is we will take across x-axis, then across y-axis we will take the BL. So why we have taken these voltages across x-axis and y-axis? Anyone know about this? Because there is a 90-degree phase difference. Okay, because there is a 90-degree phase difference right here. So voltage across inductor will lead. Okay, but across the resistor there is no difference. Okay, there is no phase difference. Current and voltage will remain the same. So right here this is the current. Okay, so this current and voltage, okay, this current and voltage, there is no phase difference. So that's why x-axis represent right here, whereas in y-axis we will take this VL because there is a phase difference of 90 degrees present. Clear everyone? And we will draw a resultant. So this is a resultant. Okay, we will draw across these two voltages. Okay, so when you draw a resultant, what you will do, you will take a perpendicular from this inductor side and you will take a perpendicular from the resistive side, and then it will meet at particular location. Okay, okay, when it will meet at particular location, that is called a resultant. Okay, that is called a resultant. So what is resultant right here? Resultant is a voltage which we will calculate. Okay, this is the resultant. Okay, so this voltage we will calculate right here. So how you will find out this voltage? As you can see, this will become a right angle triangle. Okay, this will become a right angle triangle. Okay, so this is base, this is perpendicular, and this is hypotenuse. Okay, so according to Pythagoras theorem, what will be the equation? Equation will be h square is equal to b square plus p square. So what do you mean by that? Hypotenuse ka square is equal to base ka square plus perpendicular ka square. Clear everyone? And we will move this square symbol to the right hand side. It will become a under root symbol. Okay, so you will put the voltages which we have calculated. So what is the voltage across this base? Across this base voltage is BR. So we will put the BR across it. What is the voltage across perpendicular? Across this perpendicular voltage is BL. So we will put the voltage BL, and we have also calculated the BR and BL values. We will put the value of VR, that is IR ka square, plus we will put the value of VL right here, IXL ka square. Okay, so what will be the common value from these two these two values, I will be the common factor. So it is taken out from the under root, and you will find under root r square plus xl ka square. Okay, so this r square plus xl ka square whole under root will be represented by z. Okay, so what is z? Z is the impedance, is equal to I into z, and you can calculate the current value right here. You can calculate the current value right here. Clear, everyone? Any doubt till this point? Quickly give your response. Any doubt till this point? Okay, so this is the equation. This is the equation right here. Current is equal to I is equal to V upon R square plus XL ka square. Impedance, we can say Z is equal to under root of R square plus XL ka square. And we can calculate the current value I is equal to V upon Z. So quickly give your response. If you will have some doubt, then we can clear your doubt, and we can calculate the phase difference right here. Okay, so how you can calculate the phase angle? Phase angle is this: tan of phi is equal to p upon b, tan theta is equal to p upon b. So across perpendicular we will put the value bl, across base we will put the value br, and we have already calculated these values. Uh, we will cancel out those values which are matching, and we can calculate this uh, phase angle phi is equal to tan inverse of xl upon r. And we can also find out this power factor, that is cos of phi, or we can say cos theta b upon h, and we will put these value, and you can calculate this power factor is